So this is 10.4, solving radical equations, and basically when you solve a radical equation you treat it just like you would a regular equation. And in a regular equation, when you're solving with a variable like x, let's say, the first thing you want to do is you want to isolate the variable. Same thing with a radical equation, you want to isolate the radical. So you want to get the radical by itself. Second thing you're going to do is you're going to get rid of the radical. And in order to get rid of the radical, you have to do the inverse. And the inverse of taking a square root would be to square that number. So you would square the radical, but whatever you do to one side of an equation, you have to do to both. So you would square both sides of the equation. At that point, you're not going to have a radical anymore, so you can just go ahead and solve for x. Now, one of the differences with having a radical equation is that you have the possibility of having an extraneous root. And basically an extraneous root is when you solve the problem and you get an answer, but when you plug it back in, it doesn't actually work in the problem. That would be considered an extraneous root. So let's look at this first problem. My first step is I want to get the radical by itself. So I'm going to isolate the radical. I'm going to move over the 4. And that'll give me negative radical 2s equals negative 10. I have to get rid of the negative, so divide by negative 1. And I end up with radical 2s equals positive 10. At this point, you really want to look and make sure that the radical is equal to a positive, because now my radical is by itself, but it cannot equal a negative because then it would be a no solution. So in this case, it equals a positive, so I can go ahead and continue. So my next step is to square both sides because we want to get rid of that radical. And if you square it, that will cancel out the radical. So you're going to be left with just 2s equals 10 squared, which is 100. Divide by 2, and you get s equals 50. Now I have to make sure I don't have an extraneous root. So what I'm going to do is I'm going to check it. And you don't have to do this written. You could do this mentally. But I'm going to go ahead and write it out for you just so you can see. So I'm just plugging it back in to see if it works. And it does. I end up with negative 6 equals negative 6. So yes, this is a solution. Okay. Why don't you go ahead and try the next problem. Okay, so there is the answer to that problem. Check it and see if you did it correctly. Alright, so this next problem is already isolated. So once it's isolated, my next step is to look to see if it equals a positive or a negative. And it equals a negative, which means I'm going to have a no solution. And the reason is because nothing inside of a radical is going to come out as a negative number. It's always going to come out as a positive number. So this can't work. Okay, let's move on to number 15. This is already isolated. Don't be fooled just because there are two radicals. If one side is isolated, I go ahead and square both sides to get rid of the radicals. That's going to cancel out my radical. And I'm left with x plus 7 equals 15 minus x. And then I solve it like a regular problem. So I add x, subtract 7, and divide by 2, and I get x equals 4. If I plug that back in, 4 plus 7 is 11, and here 15 minus 4 is 11. So square root of 11 equals square root of 11. It works. Okay? Now you'll also have problems that are going to end up giving you quadratics. I'm going to do this one over here, and then you can do number 17 after. So my radical is already isolated. It's on this side, but it's okay. And it does equal a negative variable, which is okay because the variable, we don't know what that stands for. It could be a negative number, which would make it a positive. So we can go ahead and solve this problem. It's not the same as when it equals a negative number. So I'm going to go ahead and square it because the radical is already by itself. That's going to cancel out my radical here and leave me with y squared because negative y times negative y is y squared over 4 equals negative 5y. So now I just put what's under the radical because I've canceled out the radical over 4. So since if I multiply by 4 on both sides, these would both cancel. I can go ahead and eliminate the 4. It's also like finding, it's also like clearing fractions, right? So I cancel out the 4 on the bottom. So I end up with y squared equals negative 5y plus 24. Now, this is a quadratic because I have a y squared. I know it's a quadratic, so I want to move everything over to the same side. So I'm going to go ahead and add 5y, subtract 24, and put in order, standard form. Okay, so now I have a quadratic. I can solve it in many different ways, completing the square, quadratic formula, but this one factors, so I'm going to go ahead and factor first. Okay, my signs are going to be different. Factors of y squared are y and y. And then the factors of 24 that subtract to 5 are 8 and 3. I do my check. 8y minus 3y gives me 5y, so I know I did it correctly. And then I go ahead and put each parentheses equal to 0. And I get y equals negative 8 and y equals 3. Now we do our check, right? So when I plug it back in, if I plug in negative 8 here, I'm going to get positive 8 over 2, which is 4. And if I plug in negative 8 here, I'm going to get positive 40 plus 24, which is 64 over 4, which gives me 16. And the square root of 16 is 4. And that's what I got here. 8 over 2 is 4. So this one works. Now I'm going to plug in the 3. If I plug in the 3, I get negative 3 over 2 equals this radical. I don't even have to keep going because negative 3 over 2, if I have a radical equal to a negative, it's a no solution. So automatically that one is not going to work. Go ahead and try number 17. So here's the answer to 17. And it does end up being quadratic. You have to move over the 9a and put equal to 0, and it does factor easily. Now I get my answers 4 and 5, and when I plug them both in, they both work. So both are solutions. There are two solutions to that problem.